on here to gain access to these resources and use the ones that are relevant and applicable to your development efforts. Now we'll cover some actual success stories about how companies utilizing NVIDIA GPUs and Clara software have brought transformational products to market, along with NVIDIA's Inception program for startups and industry innovators. Catalyzing success stories is the goal of NVIDIA's Inception program, which focuses on startups, in this instance healthcare companies who are doing breakthrough work in AI or compute applicable to medical devices. NVIDIA Inception enables them with the latest technology and nurtures them as they develop their applications on the Clara platform. Currently, the Inception program covers over 1,200 healthcare companies. If you are doing innovative AI or compute work in healthcare, I would encourage you to contact NVIDIA or PNY about Inception program particulars. Now let's look at some success story examples drawn from the Inception program. One of them is InfraVision. They have created a CT scan tool that assists radiologists diagnosing lung cancer. Pre-InfraVision, a typical image series would require 15 to 20 minutes to evaluate. Now, with an NVIDIA GPU and Clara Platform Assist, their AI can identify and label lung abnormalities in under 30 seconds. They also have an AI that can identify and categorize COVID-19 lung damage. Another interesting example is Calibre AI. They provide AI-assisted endoscopic video feeds for surgery. The AI actually guides the surgeon by suggesting where to look, what to look for, and what to do. Real time for real life-saving results. Calibre's models were trained on NVIDIA RTX GPUs, specifically an RTX 6000 at the edge, while inferencing is performed in the device by an NVIDIA AGX Xavier and Jetson TX2, which working synergistically together bring real-time video processing and AI inferencing to the operating room. Finally, let's review a hearing aid developed by Columbia University that hones in on one voice among many, just like the human brain, unlike a traditional hearing aid, which amplifies all voices equally, making it difficult for wearers to focus on a single speaker in crowded, noisy settings, the aptly named cocktail party effect. Columbia's GPU-powered AI hearing aid monitors brainwaves, determines who the wearer wants to hear, then boosts the selected voice, all within 2 to 3 seconds. A wonderful example of how AI inferencing at the edge can work all the way down to consumer devices and products. Now let's deep dive into the GPU hardware platform side of the business equation, the foundation on which everything else is built. NVIDIA's latest Ampere architecture-based products continue to deliver on NVIDIA's commitment to offer better performance per watt alongside significant new features. The NVIDIA RTX A6000 features second-generation RT cores optimized for ray tracing, which offer 2 times the performance of the prior generation, along with additional features and benefits. Third-generation Tensor cores complement RT cores with AI features like deep learning supersampling and AI denoising, both of which improve graphics quality and performance. New TensorFloat 32 and bFloat offer up to 5 times performance gains over the prior generation and can be quickly implemented with only minor code changes. CUDA core efficiency is significantly enhanced by double-speed processing for single precision FP32 floating point operations, which are up to 2 times more power efficient than Turing architecture GPUs. You can also run floating point and integer calculations in parallel simultaneously. PCIe Gen 4 doubles the bandwidth of PCIe Gen 3, now 64 gigabytes per second, improving data transfers from the GPU and memory for data-intensive tasks, especially with GPU direct storage compliant devices.